Welcome to Daily Papers, the podcast where we break down the latest and most interesting research papers into something you can actually understand.
Today, we're talking about AI. Specifically, those AI assistants we're all getting used to, the ones that browse the web, answer our questions, and even help doctors. They're getting incredibly smart, but they have a surprising blind spot.
It's a blind spot this paper from Carnegie Mellon University really shines a light on. The paper is called Mitigating Modal Imbalance in Multimodal Reasoning, and it asks a simple question. What happens when an AI gets conflicting information from different sources?
Right, think about it. When you browse a shopping website, you see images of a product, you read a text description, maybe you see prices in different currencies. That's all different types of information. In AI speak, each of these types is called a modality.
So text is one modality, images are another. Different languages like English and Chinese can also be thought of as different modalities. Modern AI, often called multimodal AI, is designed to understand all of these at once. But how well does it actually do that?
To find out, the researchers basically tried to trick the AI. They set up what they call cross-modal conflicts. It's like showing an AI a picture of a pink watch, but giving it a text description that says the watch is gold, and then asking, what color is the watch?
A human would immediately say, hang on, the picture and the text don't match. You'd spot the conflict. The question is, does the AI?
Well, the researchers first tested the AI with conflicts inside a single modality. For example, they'd give it 2 paragraphs of English text that contradicted each other. In one paragraph, it says 4,000 protesters showed up. In the other, it says it was only a few hundred.
And in those cases, the AI was actually pretty good. It could recognize that the 2 pieces of text disagreed about 90% of the time. It successfully said, hey, these 2 things don't line up.
But here's where it gets wild. When they split the conflict across modalities, say one piece of information was in English and the conflicting piece was in Chinese, or one was in a picture and the other was in text, the AI's performance completely tanked.
How badly? The success rate for spotting the conflict dropped from that 90% down to as low as 3%. That is a massive failure. It's like the AI just picks one source and completely ignores the other.
So the next big question is, why? Why is the AI so bad at this? The researchers hypothesize it's due to something called cross-modal attention imbalance.
Attention is a key concept in how these AIs work. You can think of it like how we pay attention in a conversation. If 2 people are talking to you at once, you might find yourself focusing more on one person and sort of tuning the other one out.
That's exactly what the AI is doing. It's paying way more attention to one modality and essentially ignoring the other. The paper shows that when given English and Chinese text, the AI pays much more attention to English. And when given text and image, it pays way more attention to the text.
It has a favorite, and it's not even trying to hide it. The researchers proved this was the cause with a really clever experiment. They went into the model's brain, so to speak, and manually turned up the attention on the ignored modality.
It's like forcing yourself to listen to the person you were tuning out. And when they did that, when they artificially balanced the attention, the AI suddenly got much, much better at spotting the conflicts. This showed a direct link. The attention imbalance was the problem.
Okay, so we know the problem and we know the cause. How do you fix it? The obvious first step might be to just throw more data at it. If it's bad with images, show it more images. If it's bad with Chinese, train it on more Chinese text.
But the paper shows that this simple approach, which they call dataset level mixing, doesn't really work. It's like teaching a student French on Mondays and Spanish on Tuesdays. They might get good at each language individually, but they won't necessarily be good at comparing the 2 in real time.
So the researchers came up with a much better solution they call instance-level modality mixing. It sounds technical, but the idea is actually very simple and elegant.
Instead of giving the AI separate, clean examples, one all in English, one all with images, you mix them together in the very same training exercise. So you give the model an instruction that includes both a picture and text. And you tell it, reply to both user instructions. You force it to juggle from the very beginning.
Going back to our analogy, it's like having two people talk at you. You get them to talk to each other. Now you have to pay attention to both to follow the conversation. You're training the AI to handle the messy, mixed-up way information comes at us in the real world.
And it worked beautifully. This simple training method significantly reduced the attention imbalance. As a result, the AI became far better at spotting conflicts between different types of information. Even better, this doesn't require creating expensive new datasets. You can just remix existing ones.
So, what's the big takeaway here? As we start to use AI for more important tasks like navigating a map, summarizing medical records, or even just buying the right product online, we need to be able to trust it.
Exactly. The paper gives a great example. An AI agent is told to buy a Hawaiian shirt. It sees a picture of a plain white t-shirt, but the text description underneath calls it a Hawaiian shirt. A bad AI would just go ahead and try to buy the t-shirt. A good AI, one that has been trained to handle these conflicts, would flag the discrepancy.
This paper shows us a fundamental weakness in how many of today's AIs are built. They're not great at combining and cross-referencing different types of evidence.
But it also gives us a practical, scalable way to fix it. The solution isn't just about having more data, but about having smarter data. Data that forces the model to learn how to reason across the different ways we communicate. By training our models to reflect the complexity of the real world, we can make them a whole lot more reliable.
A fascinating peek under the hood of AI showing that even the smartest systems need to be taught how to pay attention properly. That's all the time we have for today.
Thanks for tuning into Daily Papers.